Okay, so here on the first slide is just a review from the last section on using our calculator. If you want to take a minute, pause the video, you can go in and make sure you still remember how to put these into the calculator under Math 0 for the summation. And if you do them correctly, you should get the first one should be 31, the second one should be 25, the third one should be a big old fraction, 25,220 over 2,187, and then the last one should be negative 531,440. Okay, so now we are going to look at infinite geometric series, which means they get bigger or smaller by a ratio, just like the geometric series did before. However, this time it's going to be infinite, and when we are working with infinite geometric series, we are not going to be able to use the calculator with the summation. We are actually going to have to use this formula right here, which is S equals A sub 1 divided by 1 minus R. And a couple of things to note is that, again, we need to remember how to find that common ratio. To find that common ratio, we take a term and the term previous to it and simplify that fraction, and that is going to be our common ratio. The other important piece is that not all infinite geometric series have sums. If you find the ratio, and the ratio is, let's see here, between 0 and 1. That means that R is going to be a fraction or a decimal between 0 and 1. Then the series has a sum and you can use the formula. If R is greater than 1 or less than negative 1, then it has no sum, and if that's the case, then you just say there is no sum and you move on. So let's take a look here. We're going to use our formula right down here where the sum, and if you notice it has a infinity symbol right here. That means we're finding an infinite series sum. Okay, and in order to do that, we have A sub 1 divided by 1 minus R. So the things that we need to make sure we know, first of all, is what is A sub 1 and what is R? Well, as you look at this problem here on letter A, we first should note that we're going to infinity. If we are going to infinity, then we're going to have to use that sum. The second thing that we notice is here is our rule, okay? And we know that if we are in a geometric series and we have the rule, this first 3, that's our A sub 1, so we know that A sub 1 equals 3, and we know that this is our R, so R equals 0.7. And really, if you look at our formula down below, all you need is those two values. And you can use your calculator and stuff to figure some of this stuff out. But when we go to find our sum, we would have our sum, which we'll call S, equals A sub 1, that's 3, over 1 minus R, which is 0.7. So that's going to be 3 over 0.3. If you go ahead and put that into your calculator, your sum is going to equal 10. Okay, and then this one, it actually just gives you the geometric series rather than giving you the rule, which means you're going to have to do a little bit of calculating of some information. First of all, we know A sub 1 is 1. Okay, we also know our R value, if we take any two terms, write them as a fraction, 3 over 1, which is just 3. We're multiplying by 3 every time. And we put those into our formula. Our sum is going to equal A sub 1, which was 1, over 1 minus R. Hang on. Let's go back because I got all going too quick here. We need to remember that if our R value right here is greater than 1, there is no sum. So we're going to have to make sure we're thinking about that. That one caught me off guard there for just a second too, so it happens. But just make sure. So like on letter A, our ratio is 0.7. That's a decimal between 0 and 1. And on letter B, our ratio is positive 3. 3 is a whole number, is a number greater than 1, which means there is no sum on letter B. Oops, I don't want to do that. Okay, so let's just take a look and do a couple more here. This is just a infinite geometric series. We know it's infinite because it has the dot, dot, dot at the end. We know that a sub 1 equals 2/5 because that's our first term. Our ratio, if we look, and we can kind of look just at some stuff logically here. If we look at what's going on with our numerator and our denominator, okay, our numerator is going times 2 every time, and our denominator is going times 5 every time. So actually our ratio is 2/5. We also could have said, if we wanted to think about it as 4/25 over 2/5 if we multiplied by the reciprocal. We would still, if we cross simplified, we'd still get 2/5. So putting it into our formula, we would get S equals a sub 1, which is 2/5, over 1 minus 2/5. Okay, so then we have to think 1 minus 2/5 is 3/5. I'm going to erase a little bit of this here because that's kind of in my way. Maybe it doesn't erase very good. So our sum is going to be 2/5 divided by 1 minus 5/5. That's like 5/5 minus 2/5 is 3/5. And if we multiply by the reciprocal, 2/5 times 5/3 is 2/3. So our sum is going to equal 2/3. Okay, so let's take a look at the next one, and just keeping in mind that we want to think of this first 3 as like 3/1. Okay, so if you look, a sub 1 our a sub 1 is 3, our first term is 3, or 3/1. Our ratio, if we look, it's 3 every time, and we are in geometric, so that's basically multiplying by 1 in the numerator each time, and times 4 in the denominator each time, because 1 times 4 is 4, 4 times 4 is 16, 16 times 4 is 64. If we put that into our formula, we would have 3 in the numerator and 1 minus 1/4, which is 3/3, which is the same as 3 times 4/3. So our sum is going to be 4. Okay, now we just have it written in a slightly different way. We're just going to use that same formula again. We have our a sub 1 equals 3. Our ratio is 5/4, because those are what those numbers actually stand for. 5/4 is greater than 1, which means in this case there is no sum because our ratio is greater than 1. Okay, on this next one, okay, there isn't any numerator out in the front, which means our a sub 1 equals 1. Our ratio is -1/2. So if we said 1/1 minus -1/2, we'd have, that's the same as adding a half, so we'd have 1/3/2, which means 1/3/2 equals 2/3. So our sum is going to equal 2/3. We can put these into a couple of story problems and we can figure it out. A pendulum, that's like if you had a ball hanging on a string and it just went back and forth. Eventually that pendulum is going to stop swinging, which means your ratio is going to be less than 1 because each time it's getting a certain amount smaller, which is also basically an explanation for why you will have a sum when your ratio is less than 1, because eventually you hit where like the pendulum will stop swinging so you can actually find a sum. If your ratio is greater than 1, your numbers keep getting bigger and bigger and bigger and bigger without any kind of an end or any kind of a stopping point, which means you can't find a sum. But on here, we just need to look at the diagram, and it tells us everything that we need to know. Okay, the first time the pendulum swings, it swings 18 inches. Okay, so we can say that our a sub 1 is 18. Okay, our ratio, well, looking at the diagram here, or in the story problem, it says the pendulum travels 80% of the distance of the previous swing, which means our ratio is 0.8, because that's 80%. So in order to find the total distance, if we calculated every time it swings back and forth, it's going to swing a little bit shorter every time, and the total distance that it would swing would be our a sub 1, which is 18, over 1 minus 0.8, and you can put these into the calculator. 18 divided 1 minus 0.8 is 0.2, which, so our distance, the sum, the total distance it travels, is 90 inches. Okay, another common type of situation would be where something is getting less and less. It says, and you can read through the story, but basically our station is giving away $300 the first day, and then each day it becomes 95% of that, so it goes a little bit less and less and less that they will give away each day, until eventually you'll get to the point where there is nothing left to give away. So we would have our a sub 1. Well, the first amount they give away is $300. Okay, and then our ratio, or our rate, is going to be 95%, which is 0.95. We can write that as a decimal, and then we just need to calculate it out. We'd say a sub 1 is 300. 1 minus r, 1 minus 0.95 equals 300 divided by 0.05, which gives us $6,000. So they, over the course of time, if they did this game, they would give away a total of $6,000. Okay, the last thing is, a lot of times you have repeating decimals, like 1/3 is a repeating decimal, 0.333 repeating. Okay, and most of us know that that's 1/3. But there's a lot of these that we are not as familiar with when we have repeating decimals, and there is a way to use this formula so you can figure out what the repeating decimal actually, or excuse me, what the fraction is that corresponds to the repeating decimal. So we have, first example here is we have the decimal 0.24242424. That 24 is repeating all the way out to infinity. So the first thing that we do is we rewrite the repeating decimal as an infinite geometric series. So what that looks like is our first term, is going to be whatever that first repeat is of our decimal. So we're going to have 0.24 plus, well, we've taken care of that first 0.24, so then we have 0.0024. So if you add those two together, you get 0.2424 plus so now we've got the first 4 decimal places, 1, 2, 3, 4, and then we repeat 24 plus, and it just keeps going on and on and on. So our a sub 1 is 0.24. Okay, our ratio, there should be a decimal right there, is we take a term and the one previous to it, 0.0024 over 0.24, okay, which is 0.01. We can put that in our calculator and it's 0.01. So r is 0.01. If we put our values now into that formula, a sub 1 is 0.24 over 1 minus 0.01 is 0.24 over 0.99, which is 24 over 99, which simplifies to 8 over 33. So if you put 8